Okay, everybody, let's go ahead and continue on with our 6.2 notes. We are now going to use the normal model to answer these questions. So I'm going to go ahead and pull up my normal calculator here. So as we talked about before, the mean height for women is 64 inches. So I can type that in, and the standard deviation is 3 inches. For the first question, we want to find the probability that a randomly chosen woman is less than 62 inches tall. So it's already on the less than option. All I need to do is type in 62, hit compute or hit enter. And notice it gives me an image so I can double check visually that I've done this correctly. I can see that 62 and everything less is what's shaded. So this area, the shaded area, represents the probability, and right down here is where that is. So it also tells you here, just as a reminder, probability is a number between 0 and 1. So it looks like our answer here is about 0.25 or 25%. Okay, so then part B, we want to find the probability that a randomly chosen woman is more than 62 inches tall. So all I need to do on that is flip my symbol. And rounding off here a little bit, that would be 0.75 or 75%. And just as a note or a reminder from our probability unit, notice that those two are complementary. You're either less than 62 inches or more than 62 inches, and notice if you add those up you get 1, so kind of just a reminder there. And then the last one says find the probability that a randomly chosen woman is between 62 and 67 inches tall. So we do have that option on our normal calculator as well. It will do between for us, so we can put the two values that we want to check between. Looks like about 59% there. Okay, let's go ahead and move on. It says some research has shown that the mean length of newborn Pacific Harbor seals is about 29.5 inches and the standard deviation is 1.2. Suppose that the lengths of these seal pups follow the normal model. So again, because they say this, that's how we know we're allowed to use this. If we don't know that it's normal, we would not be able to use this, but we do. We want to find the probability that a randomly selected seal pup is within 1 standard deviation from the mean. Okay, so within 1, so it says the mean is 29.5, we know that. The standard deviation is 1.2. And if we want to find the probability that it's within 1 standard deviation of the mean, that does mean like an above or below, so we want to use the between here. But it means we need to go out both directions. So we need to do 29.5 minus 1.2, and that will give us our bottom value here. So the bottom value would be, what, 28.3? Here, I forgot my equal sign. 28.3. And then the upper limit would be 29.5 plus 1.2. So that would be 30.7. So when we want to find the probability between those two values, 28.3, 30.7, compute, looks like it's about 68%. And that number should not be surprising. I'm going to go ahead and write that down. We know by the empirical rule. The empirical rule tells us that within 1 standard deviation of the mean is supposed to be approximately 68%. So that 68% of data will fall within 1 standard deviation of the mean. So that should not be a surprising result. Again, it is an approximation, so it won't always be perfect, but it will be close. Just to see this worked a different way, we can rework this same question using z-scores. If you use a help me solve this, this is probably how they're going to do it. What they will probably do is convert first. So clearly we don't have to convert first and we can find the answer. We just did that. But if they lead you through this way, just know that they're doing some extra steps that aren't necessary, and they will eventually get to the answer though. So I could convert each of those to a z-score by pulling up my formula, converting the 28.3 to a z-score of -1, converting the 30.7 to a z-score of +1. And then the reason why they do this is because it used to be more standardized where you were more locked into having to use the standard normal model. You had to use 0 and 1 here. Since we have this technology, we don't have to do this. We can be more flexible. But that's the reason why they do that. So if we convert it all to the normal, to the standard normal, and convert these to their z-scores, notice that we get exactly the same answer back. So that's all we're looking for here. So it's still 68%, just a different method for solving. Please do not feel like you have to do everything both ways. You're just fine doing it this way. The only reason I'm even showing this to you is for whenever you click the help me, so that you understand what they're doing. So we already did this. Actually, it looks like this is supposed to go down here. It's still 68%. Okay, you could be asked to do these problems also in reverse. That's what we call an inverse normal problem. So what they might give you is they might give you the probability, and they might ask you to work backwards and find the measurement. A really important word to know here also is that when they say the word percentile, that's another word for probability. So if they ever say that someone is a such and such percentile, they're telling you this box, and they want you to work backwards and find this area over here. So this says, how tall would a woman in the 25th percentile be? Well, we're going back to the idea of women have a mean height of 64 with a standard deviation of, if I remember correctly, was that 1.2? No, sorry, that was 3. Sorry, different question. And we want to know how tall a woman in the 25th percentile would be. Well, you always have to do the inverse normal ones in the standard view. You fill in the mean and the standard deviation, and you enter that answer, that probability or percentile in this case, here. And another thing you always want to know is you always keep it in the less than view. And then what you want to record as your answer now is this box. So it looks like it's about, in this case, the answer would be about 62 inches. So in the 25th percentile, a woman would be taller than 25% of other women, and that would mean she is about 62 inches tall. Let's go ahead and scroll back up just to see. We were verifying one that we had already done. I believe, did we not do it here? I thought we did. Sure we did. We did it right here. The probability that a randomly chosen woman is less than 62 inches tall was 25%. So when we typed a 62 in here, we got 25%. When we typed in 25%, it should not be then surprising that we got back 62. So as you can see, the inverse normals are just working in reverse. So you do have to be careful when you read the problems, when you read the setups, pay close attention to what information they're giving you. Because this says percentile, and percentile is another word for probability, that's how I know they've given me this last blank, and they're asking me to work backwards.